Welcome to the last lesson of Chapter 11, Factoring with the Perfect Square Formula. In this lesson, you will use the perfect square formula to factor polynomials. This is the last lesson of Chapter 11, where we have learned all about the definition of factorization, as well as the different ways to conduct factorization. So far we have learned removing common factors and using the square difference formula. In this video, we'll be looking at another very important formula, which is called the perfect square formula. If you think you need some more review on this formula and how it works, I will be linking its lesson in the description down below for extra review. So here are the learning goals for today. Understand and master factorization using the perfect square formula. Flexibly apply various methods to factorize. Let's do some review. First, what is the definition of factorization? And 2, what methods of factorization have we learned so far? The definition of factorization is converting a polynomial into the form of several expressions being multiplied together. Again, factorization is the reverse of multiplying whole expressions. And we have learned the common factor method, which is using the reverse distributive property to factor out common factors, as well as the square difference formula, which is a squared minus b squared is equal to the sum of a and b times the difference of a and b. Factorization using the perfect square formula. Can you fit the following pieces together to make a square? Here we have one square, two rectangles, and a smaller square. Now pause the video and see how you can fit these pieces together so that you can make a perfect square. Here's one model you can use. Now that we have this model in front of us, how can we find the area of this square? Since it is a square, and we know that the area formula for squares is side length squared, and we know that its side length is a plus b, then one way we can find its area is a plus b squared. But the other way we can do this is adding up the individual known areas of each of these four pieces, which is a squared plus 2ab plus b squared. Since they are describing the area of the same square, these two expressions are equivalent. Reversing the above equation, we have a squared plus 2ab plus b squared is equal to a plus b squared. The equation works either way, and it's very important to be able to spot an expression in the form of a plus b squared and convert it into a squared plus 2ab plus b squared and vice versa. We call expressions like a squared plus 2ab plus b squared and a squared minus 2ab plus b squared perfect square expressions. Observe these two expressions. How many terms do each polynomial have? What are the characteristics of the first and third terms of each polynomial? Third, what is the relationship between the three terms? Well, each polynomial has three terms, making each of them a trinomial. And their characteristics is that both terms are squares of numbers or expressions and have the same sign. The middle term is positive 2 times or negative 2 times the base numbers of the first and third terms. The base numbers are a and b. So here is the perfect square formula. A squared plus or minus 2ab plus b squared. Features of the perfect square formula. 1. There must be three terms. 2. The square of two expressions with the same sign. And 3. The middle term is 2 times or negative 2 times the product of the two base numbers. Now, according to this formula, fill in the following blanks. Pause the video and work on these three problems by yourself. Alright, So this should have been your answer. Now, determine whether the following expressions are perfect square expressions. Let's do this together. The first one would be yes, since the first and third terms are perfect squares, and the middle term is -2 times the base numbers of the first and third terms. Now, when I say first and third, remember, perfect square expressions won't always have it in two perfect square terms at the end and one middle term. Sometimes their orders will be switched around. So it can get kind of confusing when you say first and third terms because the order of the terms can always be swapped around. Anyways, let's look at the second one. This will not be a perfect square expression because it does not have three terms. For the second one, it only has two terms. That's why it's not a perfect square. Now for the third one, it is also not a perfect square expression because 4b squared and -1 have opposite signs. Remember, one of the requirements was that both of the perfect square terms have to have the same sign. And since 4b squared has a positive sign and -1 has a negative sign, it means that it is not a perfect square expression. For the fourth one, it is also not a perfect square expression because AB is not 2 times the product of the two base numbers. And for the final one, yes, it is a perfect square expression because, as you can see, it meets all of the requirements. Let's do an example. If x squared minus 6x plus n is a perfect square expression, what is the value of n? And some step-up training. If x squared minus mx plus 16 is a perfect square expression, then the value of m is blank. Pause the video and solve these on your own. Okay, so for example 1, you should have gotten b as your answer. According to the characteristics of the perfect square formula, the middle term, -6x, is equal to 2x times -3. So n would be the square of -3, which is 9. How we solve this problem was that we know that in a perfect square expression there must be three terms. Two of the terms must be perfect squares, and one term must be positive or -2 times the base numbers. Since we already have a perfect square term, and we already have and since -6x is not a perfect square, it must be the middle term, which means that n must be a perfect square. This way, we are taking apart the middle term to find the second base number, which in this case is -3, and then squaring it so that we have 9. Now for the step-up training. Their answer should have been positive or -8. Since 16 is the square of positive or -4, therefore -m is equal to 2 times positive or -4, so m itself is equal to positive or -8. Here, our solution is again looking at what types of terms already exist. X squared is already a perfect square term. 16 is also a perfect square. So now we are also taking apart the middle term. Taking it apart, we are finding the base numbers. Here's our method conclusion. In this question, you must master the structural characteristics of the perfect square formula. During the calculation process, pay attention to the sign of the 2ab term. Here's example 2. Factor these two expressions. Here's our analysis for the first one. In question 1, 16x squared is equal to the square of 4x, and 9 is equal to 3 squared. 24x is equal to 2 times 4x times 3. So 16x squared plus 24x plus 9 is a perfect square expression. Splitting this up, we have 4x squared plus 2 times 4x times 3 plus 3 squared. Here, 4x is our base number a, and positive 3 is our base number b. This middle term would be 2ab. Now here's our analysis for the second one. In question 2, the first term is negative, so we must first remove the negative sign to have negative 1 times x squared minus 4xy plus 4y squared, and then the formula can be applied. Here's our solution. For the first one, you should have gotten 4x plus 3 squared, and for the second one, you should have gotten x minus 2y squared. Let's do example 3 together. Our first one is 3ax squared plus 6axy plus 3ay squared. As you can see, there is a common factor of 3a, so it must be removed first. After removing 3a, we have 3a times x squared plus 2xy plus y squared, which we can use the formula to turn into 3a times x plus y squared. Now our analysis for number 2. If a plus b is looked at as a whole, remember our holistic thinking from a few lessons ago, let a plus b is equal to m. Therefore, the original equation is m squared minus 12m plus 36. As you can see here, the first two terms have a common factor of a plus b. It's just that it's not the best idea to factor it out since the third term does not share that. But what we can do is replace a plus b with a variable, so calculations with it is easier. Now we can turn it into m squared minus 12m plus 36, which in the end we have a plus b minus 6 squared. So here is our overall concept. Using formulas to factor polynomials with special forms such as the square difference formula and the perfect square formula, this method of factorization is called the formula methods. Let's do some more training. Factor these two expressions. First, we have to remove common factors. So after factoring out the common factor negative 3a squared, we have x squared minus 8x plus 16. After factoring that, we have negative 3a squared times x minus 4 squared. And for number 2, we can first turn 16a squared into the form of 4a squared. And then after simplifying, check the factors of the polynomial for more common factors. We can turn it into a plus 2 squared times a minus 2 squared. Example 4. Factor the following expressions. And as you can see here, instead of variables, we are given numbers. But just like the square difference formula, the perfect square formula can also help make simplifying numerical expressions easier as well. This question uses the perfect square formula to factorize. Now pause the video and try this on your own. Numbers and variables still work the same. We first need to identify the two base numbers, which in this case would be 100 and negative 99, or minus 99. After factoring, instead of having to do all of this multiplication, we can just do 100 minus 99, which is 1, and then square that, which is equal to 1. Simpler than you realize. And for number 2, we can first identify the base numbers, which is 34 and 16. After factoring that, we have 2,500. Example 5. Given that x squared minus 4x plus y squared minus 10y plus 29 is equal to 0, find the value of x squared times y squared plus 2xy plus 1. Now this is a trickier question and it does require more complex thinking into it, but here's a hint. First, simplify it into the form of the perfect formula. Alright, since we are given that this expression is equal to 0, then x minus 2 squared plus y minus 5 squared is equal to 0. X minus 2 squared has to be greater or equal to 0, and y minus 5 squared has to be greater or equal to 0, because any square has to be greater than or equal to 0. But if the sum of several non-negative numbers is 0, these non-negative numbers must be all 0 itself. Therefore, x is equal to 2 and y is equal to 5. And now finding the value of this second expression. Before substituting, we always simplify. So first we can simplify this into the factored form of xy plus 1 squared. And then substituting in the values of x and y, we have 121 as our final answer. I suggest you to pause the video and really think about how we went through this question. And the key point here is to see how I can factor these expressions into a form that I can easily analyze. Method conclusion. The general method for this kind of problem is to transform the original expression into the form of the sum of non-negative numbers, and then use the properties of non-negative numbers to solve the problem. Example 6. Given that a, b, and c are each the sides of the triangle ABC, and a squared plus 2b squared plus c squared minus 2b times a plus c is equal to 0, please classify triangle ABC along with your explanation. So by classifying triangle ABC just means, is it, equilateral, is it isosceles, or is it scalene? So anything like that, or right triangle, acute triangle. Pause the video and try to classify triangle ABC by yourself. Alright, since we are given that this expression is equal to 0, then a minus b squared plus b minus c squared is equal to 0 after factorization. Therefore, a minus b is equal to 0, b minus c is equal to 0. A is equal to b is equal to c. And this is using the same logic that we used for the previous problem, which is if the sum of several non-negative numbers is equal to 0, then each of these non-negative numbers has to be equal to 0 itself. Triangle ABC is an equilateral triangle, since any triangle with all three sides of the same length is called an equilateral triangle. Class summary. Today we factored with the perfect square formula. The formula, which is a squared plus or minus 2ab plus b squared, is equal to a plus or minus b squared. Its features is that it must be a trinomial. Two terms must share the same sign and can be expressed as the square of an expression. The other term must be 2 times the base number of the two other terms, and its sign can be positive or negative. Today we understood and mastered factorization using the perfect square formula. We were also able to flexibly apply various methods to factorize. Thank you so much for watching 3 Inquisitive Kids. Factoring polynomials is a skill that is very important later in algebra, and I highly suggest you to completely master this unit before moving on. Again, these two expressions are something that we have been talking about for a long time now, and now you probably realize why learning those earlier in your math careers was so important. This just keeps getting more complicated and more interesting and more fun as you move on in your mathematics journey. But anyways, thank you so much for watching 3 Inquisitive Kids, and we'll see you next time.